Okay, let's start example 2. Example B. Okay, a study in March 2006 shows that the mean length of a phone call on a cell phone was 3.25 minutes. Okay? A researcher believes that the mean length of a call has increased since then. So, when you read this, so now you can imagine in 2006, a researcher or a research organization took a sample and they asked what is a mean, just the length of your cellular phone call. Well, and at that time the mean was this. So now the researcher believes that the mean length of call has increased since then, whatever the evidence or he has or she has on mind. Well, in my opinion, it is like, in some sense, it could have increased because back then, 2006, you guys were so young, right? You were in elementary school in the 2nd grade or something like that, all right? Well, back then, we had all the minutes. We bought the minutes. So 300 minutes per month or 500 minutes per month, things like that. So each minute, well, we had to save. Okay, we had to save. Well, that's why we do not make really unnecessary phone calls back then. Now what? Unlimited phone calls and the unlimited text. Well, unlimited data. Just we go on to this unlimited style of, just a lifestyle. On the other hand, people text a lot. Okay, people text a lot, so that may just have this cause some decrease in this phone call length. I don't know. But anyhow, this researcher believes that the mean length of call has increased. So this is regarding what? This hypothesis is regarding a statistical value of this population. So this is regarding mean length of this. Right? We talk about what? We talk about whole America. So this is going to be regarding mu. Okay? Regarding mu. So let's make what is null hypothesis over here. Null hypothesis is like a reigning champion. It is like old data. That is old data. This is it. Okay? So we don't have to say 2006 or 2010. Those things doesn't matter. Everything is understood. And what is important to pick up over here is mu of H naught is mu equals 3.25 minutes. Even minutes in the parentheses, okay? 3.25. And what is the alternative one? Alternative one is the researcher thinks this one has increased, okay? So the researcher has to collect data to support that claim, okay? So this is mu has been increased, so mu is greater than 3.25. Earlier we said that, we said the P equals 0.62 and this one is H naught and H1 is challenging that, so P is not equal to 0.62. In this case, we allow above 0.62 or below 0.62. That's why it has a two-tailed test. But in this case, we just think about only one case, which is mu is greater than old data, 3.25. Therefore, we say this is go to the right, correct? Okay? This is 3.25 and we go to the right. Therefore, we say this one right-tailed test. Okay, so this one suggests that this is right-tailed test. It makes sense, right? Okay, it is a right-tailed test. Well, so when we do that, again, this researcher is going to decide that we are going to reject this H naught or we do not reject H1. Okay, alternative hypothesis. Okay, I'm sorry, whether we reject H naught or we do not reject H naught. Okay, when we do reject H naught, that is like what? Yes, this H1 is a true one. Okay, so that's why we do it. But again, we do not use the word accept. So we only use, it's like a courtroom, a person is found guilty or not guilty. Why they do not say word innocent? Because we do not know the whole truth. Okay? We do not know whole truth. All we can say is, well, it seems that the person is not guilty. All right? So in this case, the same thing. All we can say is we do reject H naught or we do not reject H naught. So when we do reject H naught, that means this H1 is true. That's why we believe. Okay? That's what we are going to say. So the right test, the two-tailed test, those things, yes. The real testing is starting next class. So the next class is the earlier example was about population proportion, and we are going to separate two cases, population proportion and the population mean. Okay. So again, we are going to think, well, just we went through a test, and again we said only there are two possibilities. We do reject or we do not reject. So, can we make a mistake? Oh, of course. Yes, we can make a mistake over here. So again, we are going to summarize what is going to be our conclusion over here. So this is a reality, and this is a conclusion. And there are okay. So the first case is H naught is true and H1 is true. Or two possibilities, one way or another. Okay? And the conclusion, okay, I'm going to put it this way. Conclusion, go outside here. Conclusion is we do not reject H naught, and we do reject H naught. So again, always it is about H naught. Okay, about H naught. H1 is true or not true. That those things just as a result of rejecting H naught, this is going to be true like that. Okay, so H naught, all the spotlight goes on to H naught. Okay, and this is only just a supporting character over here. So H naught is true, and we do not reject H naught. Okay, that's correct. So in our language, what is that? The mean length of a phone call on a cell phone. Okay, it's not a regular landline or anything. Okay, cell phone is still 3.25 minutes. Still true. That's what that is. Okay, is it correct? H1 is true, so it's greater than 3.25 minutes. Longer than that, longer than before, longer than 2006 data. Well, that one is true, but we do not reject H naught. Still, we hold on to this old data. That's what that is, right? Okay, we still hold on to old data. So in that case, we say this is type 2 error. Okay, type 2 error. And in this case, H1 is true, and we reject H naught. Okay, we can embrace only one thing. So H1 is true, and we reject H naught. So this is also correct conclusion, if this is a case. Okay. On the other hand, over here, H naught is true, but we do reject H naught. That's bad, right? Okay. Still, just the like old days, our just mean length of this our phone call on any cell phone is that 3.25 minutes, and then we reject it. Well, this is type 1 error. Again, in our language, well, what's the big deal? Okay, the mean length is 3.25 minutes or 3 or 4 minutes or 2 minutes and 30 seconds. What's the big deal, right? It doesn't sound like a big deal to us, okay? It doesn't have any kind of significant implication afterwards. On the other hand, again, so that's why I want to emphasize type 1 error is like, again, what? Innocent person, okay? Innocent person was accused. That person, the innocent, was rejected over here. We do reject H naught, okay? So we rejected that person's innocence, therefore we throw him into jail. That is type 1 error. When you look at that way, that is a very significant error over here. Okay. And earlier I said alpha is a probability that making a type 1 error, right? And the beta is a probability that making a type 2 error. See, there are only 4 possibilities over here. Only 4 possibilities. These 2 are correct. Making mistakes over here. One kind of mistake, another kind of mistake. Look, alpha and beta, this case is H naught is true, and this case is H1 is true. So, if alpha value goes up, and then what? And the beta will go down. Make sense? If the probability that this one goes up, and then beta goes down, and vice versa. Okay, that is anything about alpha and beta. And we call this one right-tailed test. Whenever it happens, like we are claiming something is that a researcher is claiming that this one could be mu, or this one could be sigma, standard deviation, or even before, like the population proportion. Whatever the characteristic we picked, that one is greater than this old data, we are going to use right-tailed test. Okay? All right. And of course, how to do those tests? Yes, mathematically, by hand, by calculator. Yes, we are going to learn it next time.